Abdul, we will answer your question in the last. We will get started with the class. So I'll start from the place where we left yesterday. So yesterday we were talking about yesterday we were talking about this a gate level simulation. Gate level simulation is for the designer to check whether his design, when translated to netlist, is um, is correct, whether the netlist is has whether the synthesis process has made any flaws during synthesis and has introduced some logic for checking that this gate level simulation is done. Not only at synthesis, but also the further upcoming steps like after floor planning, placement, CTS, routing, everywhere. After every step, there will be gate level simulation done by the designer to ensure the functionality. Whether it is able to, the netlist is able to do this functional verification. So look at this message. Okay, so now normally for doing simulation, you will have your RTL, then you have your test bench, then you'll be able to observe the output waveforms or outputs. Okay, and through test bench you pass inputs, right? Through test bench you pass the inputs, and you will be able to observe the outputs through the test bench itself. Here, what will you will do is when you are doing your netlist based simulation, when RTL is replaced using netlist, then you will have a test bench. Also, you will have, and yeah, outputs is the simulation. Also, you will have the Verilog models. It's called Verilog models of the components that are there in the netlist. So what are there? What are the components that is there in the netlist? What are the components that are there in the netlist?
Combinational components.
Yeah, combinational and sequential components, right? So you have combinational gates and you have sequential gates. So for this, all the combinational gates and sequential gates in PDK itself, as the PDK already has the .lib for both the things, standard cell .lib. The PDK also has the Verilog models for all the flip-flop and all the gates that is there in this library. It will have the Verilog models. So once you add these Verilog models along with the netlist, then your netlist is complete by itself. Otherwise, whatever that is there in the netlist, the D flip-flop or the inverter that is there in the netlist is meaningless. It doesn't show any meaning in doing a simulation it will say that it is not able to find out what this D flip-flop means, what is this inverter means, what is this AND gate means. So for doing simulation, you need the corresponding Verilog models for all those all the cells that is there in the netlist. Any doubt? Any doubts? Yes, Lakshmikant?
Sir, yesterday I couldn't attend the class, sir. So might have missed the major things, I guess.
Yeah. Okay. So I think, see guys, ensure to attend the class, or else in the upcoming recordings also, you make sure you see the recordings, because sometimes what I teach, right, at that time you will have some doubts. During recording you will have that doubts, and then you will forget to ask also after that.
Yeah.
Yeah, so it is best to attend the class possible.
Due to office work, I couldn't attend. Sir.
Yeah, I agree. I understand, but I'm just telling it just for the sake I'm saying.
Yeah. Even like till 8 o'clock, I tried to reach home, but I tried attending on the road itself. This one test, but I couldn't attend that also.
Okay. Fine. So Kuldeep, you want me
So
to?
can you repeat it once?
Yeah. Devdeep and Kuldeep, I'm repeating it once for you. So just as you do simulation at the RTL level, for the RTL level, you pass a test bench, you write a test bench and pass inputs through the test bench and observe the outputs. And that's how you do a normal RTL simulation. This is your RTL simulation. For doing gate level simulation, that is using the netlist, we use same RTL when it is converted to netlist process of synthesis. Using the netlist, if you want to do the simulation, then you should pass the same test bench. You can use the same test bench, same inputs you can pass, so that whatever output you are getting here, you can validate whether the same output I am getting it here. But for doing the simulation, you also need something called as a Verilog model as another input that I mentioned here. Verilog model is what is the netlist comprises of components like the combinational gates and the sequential gates. So the combinational gates and sequential lib. So each the combinational gates or the sequential gates will have its own pins, right? For example, D flip-flop will have D pin, Q pin, clock pin, and then the reset pin, correct? It has its own logic, correct? The D flip-flop will have its own logic behind that, whatever is mentioned in the dot lib. So that logic, where do you get that logic from is the PDK also has Verilog models. That is, the corresponding Verilog models will be there. If you see that, there you will have the logic behind this particular gates. What is the logic implemented? So normal D flip-flop is what your output is equal to your input. Whenever there is a clock or reset available, your D will be available at Q. So this logic, where is it written? It's not written inside the dot lib. Dot lib will have timing aspects of the design of the D flip-flop while going for when you're going for production, when you're going for manufacturing, whatever is the timing that will be there, those information are only available in dot lib. The functionality is available as part of Verilog models. So these I'll show you this one of the Verilog model that's there as part of the PDK for this up down counter that we were doing. Okay, I think then you will have more understanding. Any other doubts? I'm going to show you Verilog model, but any other doubts? Okay.
Sir,
Yeah,
sir, is
definitely.
RTL connected to Netlist?
RTL is
That
not
in
connected to Netlist. RTL is not connected to Netlist. I'm saying RTL, when
okay.
goes through the process of synthesis, it gets converted to a netlist, right? That's what I mean there.
Okay, okay, sir.
So Verilog models are already made or we make them?
Verilog models are part of PDK.
So already made, right?
Yeah, PDK is provided by
The client,
client, as in
as in who wants them to be made.
Combination
No.
of circuit and sequential circuits.
No. PDK is provided by, guys. PDK is provided by,
NDA,
Yes.
NDA.
Company.
huh?
NDA,
Chip
sir.
Fabrication company.
fabrication company.
Yeah,
Chip.
yeah. PDK is provided by the fabrication fab. Wherever you are going to target, right? If you're going to do a fabrication for say 22 nanometer TSMC, the foundry provide you the PDK.
Okay.
Yeah, so they will give you everything, the library and Verilog model, and there are a lot many other files that is part of PDK, which we will discuss on the board. So now we will see how does a Verilog model look in the PDK. Okay. Okay. So this is the up-down counter netlist. Correct. So this has this flip-flop, 4 flip-flop, and these many inverters. Correct. If you see, these are instantiated here. These are instantiated using an instance name. And this D flip-flop has its own pins, that is D, CP, CDN, and Q. And these pins are connected through these nets. These pins are connected using these nets. So basically what you are doing here is you are doing a instantiation of a module, of another module. That module name is this DFCRQ1. Similarly, you are instantiating another module which is in INV0D0 that you are instantiating. What are these modules? These are the flip-flops that is picked up from the standard cell library. And this has its own equivalent functionality that is available in the Verilog model provided by the foundry. So we'll go and see the Verilog model. See, this is the SEL 180 nanometer PDK. In that, your dot libs are available in Liberty directory. Liberty, inside that, if you have libflow slow corner, you have the dot lib availables. Got it? Now, if you want to see what are the other files provided by the PDK other than .lib, you could see so many directories: CDL, doc, GDS, lef, Liberty is what we see, Milky Way, SPC, Verilog. Okay, we will see what all these files mean in the upcoming classes. Right now we have seen Liberty. Now we are going to see what is there in this Verilog. Okay, in this Verilog, you have Tmax model and VCS sim model. VCS sim model is the one that will be used for doing simulation. Like you do for RTL simulation. Here, using netlist, you will use these files for a netlist based simulation. So if you guys remember do you guys remember what is the flip-flop name that was there in the counter? I'm opening the netlist. So this is the flip-flop name, right? DFCRQ1. Correct? Now let's see in this Verilog models, what all files are there. So these are the Verilog model files that is there. You're able to see, right? So many .v's are there. This is for and Verilog model. We were looking for, what is the Verilog model we were looking for is, we were looking for DFC, correct? What was that DFC? 1 minute.
DFC RQ1.
Yeah. DFC
RQ1.
Q. So many varieties are there. That's what I wanted to show you. See, DFC, in DFC itself, you have these many flavors of flip-flops. And DFC RQ1 is what we wanted. Okay. That's in the netlist. If you open this, this is a Verilog model. Here, this is, if you see, it has DFC RQ1, DCP CDNQ. Okay. This has information about the functionality of this particular flip-flop. These are not written by us. These are provided by the fab foundry. Okay. This has its information of how does it work. Okay. So this is the Verilog model which we will be taking and using it. This we are not going to interpret anything here. Whatever is provided by the fab it stays like that. We are not going to interpret that. We are not going to edit that, nothing. Whatever is provided by the fab is not editable. I mean, not meant to be edited. It is just to be made sure that you use it, not to edit it. So this Verilog model is also taken along with the netlist, along with this netlist up-down counter and it is, and the test bench is used to pass the inputs, and you will be able to see the functionality met. Clear? Any doubt? After seeing this, I think it should be clear. Satya sir has not joined. I think he has not joined. Okay. Any doubts? Anirudh, Shravani, Ramya, whoever answers, please tell me.
No doubt, sir.
Okay.
No doubt, sir.
Okay, got it. Okay, let me ask the question to someone. Okay. Today is Sunday, at least you should be able to unmute the mic and talk to me. Monisha, can you unmute your mic? Monisha? Monisha, can you unmute your mic? Okay, Rupa, can you unmute your mic?
Yes, sir.
Yeah, hi Rupa.
Good morning, sir.
Good morning, Rupa. Rupa, you are a student or you are working?
Yes, a student, sir.
Which year?
Third year, sir.
From?
Electronics and Computer, sir.
No, which college?
ECS. I'm from Aditya College of Engineering, sir.
Okay. Now, there is a question for you. So, at the netlist, in the netlist, what all components you are able to see? So, what is the netlist, Rupa? Rupa, you're muted again.
Sir, it is a process of synthesis where RTL will be converted to netlist.
Okay. In netlist, what all components you have?
So Verilog and
No. In netlist, what all comps
inputs.
available inside netlist? What all components you have in netlist? Anyone other than Rupa? Maybe I'll call someone. Manisha? Manisha, can you unmute your mic? Manisha, you there? Nandita Balaji, can you unmute your mic?
Yes, sir.
Yeah, Nandita, tell me, like, what are the components of the netlist are there? Inside the netlist, what do you see?
So standard cells, macros.
Good. So in the example that we were looking into, right? Like, you remember the example that I was showing for the up-down counter just now, sometime before? Where did you go again? Are you there?
Yes, sir.
Yeah. So inside the netlist, were you able to see the example that I showed you for the up-down counter netlist?
Yes, sir. Yes, sir.
Yeah. Inside that netlist, what did you see?
I don't have idea.
Okay. So why don't you then just tell me, like, if you're not able to get that, like, why don't you tell me? Because I'm spending time for you guys only, right? So you should, I mean, you are also spending time for learning. So why don't you tell me, please? Please tell me if you are not able to understand anywhere, please.
Okay, sir.
Yeah. Can anyone tell me what are the components inside the netlist?
Combination gates and
Yeah. What did you see in the example that I showed you?
Net
what are the components
Gates.
used in gate
pins.
program? Gates, inverters.
Yeah, you have
Gates,
seen the
inverters.
Yeah, you see that gates, inverters, and flip-flops, right?
Yes, sir.
Yes,
Yeah.
sir.
Yeah. So let's come back to the class. See, guys, for me it is demotivating because I don't see a response, very active response from you guys. Okay. I'm not feeling good. I'm just telling you openly. If this is the involvement that is coming from the class, then I don't see that is something that meaningful that I can bring it out of this class. So I'm asking you to someone to unmute and talk. That means you have to unmute and talk. That's the point, okay? It's not going to be like this. Like I am looking into my computer screen, I'm talking, and then you doing your work. If you're attending the class, then you are attending the class. It's not like you attend and just for the namesake of attendance, and then you see the record. You have the liberty of seeing the recording just to reassure whatever you are learning. That is the purpose of recording the class. It's not like you just attend the class and then you look into the recordings and learn. That is not going to work. I hope everyone understands what I'm saying. Can you give an emoji for that, like if you have understood?
Yes, sir.
For those who are keeping yourself in mute and not going to unmute, okay, whenever I am saying, I'm going to make you, I'm going to leave, I'm going to push you out of the class, okay? and then I'll mark your name. Just remember from here on. I'm going to mark your name and I'm going to pass it to physics wala. Tell them these people are not required for the class. Okay. I'm going to be serious hereafter. If you are not, if your involvement is not satisfactory, then what is the point of this class? Just remember, if I'm going to from now on, if I'm going to ask you to unmute and talk, you are going to talk. Else, I'll check you out from the class itself. I am a co-host. I'll be able to remove you from this meeting at all. Meeting. So just beware of that. I'm sorry if I'm harsh, but that is how it's happening. Okay.
Hello, sir.
Yeah, Abdul. Tell me.
Sir, I have a doubt, sir.
Tell me.
Sir, I'm getting confused while you're teaching about synthesis and simulation. Can you please tell that, sir?
Synthesis and simulation.
That's a
So,
difference.
okay. Do you know what is simulation? Which I taught you last couple of weeks before, RTL simulation.
No, sir. I'm also unable to join the ST session, sir. I have
Not yesterday, I'm saying. I'm not saying yesterday. This RTL simulation was taught few weeks before. How do you write a Verilog code, and how do you write a test bench on that? How do you pass inputs to the test bench? Do you know that?
No, sir. Sir, I have college on Saturday, sir. So I just attend the classes on Sundays only, and then seeing the records.
Yeah,
records
so you should have seen the recording for those things, no? So that means you should have learned that. My question is correct?
Yes, sir.
See, Abdul, it's not only I'm telling it to you, I'm saying to the entire class, okay? You guys are paying and you're attending this class. You're not doing it for free of cost, and you should at least value that. At this point of time, if you are coming and asking me the difference between simulation and synthesis and you don't know what is simulation, this is not for only Abdul, I'm saying others who doesn't know what a simulation is. It is going to be very painful. And at every class I am saying I will not come back to the class that I am going to teach, because that will affect my upcoming topics which I am prepared to teach you. So Abdul, what I'm saying is you go look into the recordings. Next class, next Saturday, you come. In the starting Saturday, you will be able to come in the next coming Saturday.
Yes, sir.
5 o'clock in the evening. You don't have college, right? Next Saturday.
Yes, sir.
So you come. If you have the doubts after looking into the recording, then I will answer your question. But I don't think so you will have a doubt, because whatever I have taught in the class, it's more. I'm teaching it to a very ground level. I'm not at all going to upper level at all. I'm teaching it in a very base level itself. So it should not, you should not have any doubts. But in case if you have doubts, I'll be happy to clear that. Okay, is it okay?
Yes, sir.
Yeah. I have only 1.5 hours in my hand, right? So I'll not be able to revisit every time the topics that I handled it already. Okay, let's not waste the time. I'm continuing now. Any other doubts, obligations, any other things? Let's clarify today itself. Okay, just remember, if I'm asking someone to unmute and talk, you are going to talk. Else I'm going to remove you from the class.
Sir, one issue is that the test timing is, I don't know, for me it is falling short, because yesterday also I've been unable to attempt all the questions. I've attempted 14 questions, and out of them 10 questions I've attended in a good manner, and rest of them in a hurry I have attended just. So can it be possible to increase the time? Because some of the concepts also I was unable to recall at that moment. So I was thinking about that. There was one question about. So my actual says that if it can be increased, timing can be increased.
1 minute, 1 minute. Just I'll place my thing in mute. Just give me 1 minute.
Okay.
Yeah, sorry. Devdeep, see I have given
Yes, sir.
sufficient time only. Okay, that the time that I have given is sufficient. I have taken 1 minute. Those questions are very simple. Okay, and each question it should not take more than 30 seconds. That's what I have assumed. But in case if you are feeling it is taking too much of it is taking the time is less, yeah, we will consider your query in the upcoming exams. Okay.
Okay, sir.
Yeah.
Thank
Anyone
you,
else
sir.
felt the same thing? Anybody else have the same thing, same thing on writing the exam?
Yes, sir.
Okay, Jiban also is having the same concern.
Yes.
Yeah.
Yes,
See,
sir.
actually,
I felt it, sir.
okay, okay. So we are actually abiding to the standards that we do it for IIT. Okay, so that's why given that way. We'll see.
Sir, did the
And sir,
PW
one more
test?
request is that
Yeah.
Sorry, sir.
one more
Please,
request is that can we get the questions in a document form so that we can have the questions with us? It would be helpful for the any future events or revising it.
We'll see. I don't know. I have to check with physics wala about this. How does that work?
Just like the notes that the class notes that are being uploaded, just like that, if it can be uploaded 15 questions in a document form so that we are able to revise whenever we need that.
Yeah, fine.
If
I'll see that. I
if
think
it can be done.
yeah. I understand.
Because the previous test that happened, which I was unable to attend, I've asked the team for sharing the questions, and they have told me that it is not the way their test work, so they can't share the question. So
Yeah,
my concern is that
that's
if we
yeah, that's a valid point, right? That's not the way.
so I got it. I
Uh,
got it. But if the question, if you are having the question and it can be helpful for the, let's say, interview round or generally for revising the concepts, right? So my concern was that only. If we have the
I don't know.
question
I'll
with
have to
us.
check with physics wala on this, okay? Because
Okay.
that's not the policy also.
Okay.
Okay. So let's see. Yeah, Biswajit, you want to say something?
Yes, sir. Did physics wala contacted you of this which modules are questions will be prepared on which modules?
What is that?
The questions whatever we faced yesterday, did physics wala contacted you that which modules the questions should be prepared? Because
No,
I see they whatever they
that
have
is my
mentioned in this
decision.
chart, modules
That
will be
is
2 and 3. Okay, but recent 4 and 5th modules also questions appeared. So this miscommunication is happening.
no, that is not a
So
miscommunication, sir. So it is my decision to take up the question. It's not with the physics wala. So whatever I have taken.
no, sir. No, I don't agree with this one because it was pre-communication as well as same day also communication that module 2 and module 3 will be coming in the question. Okay. But that's why I'm asking, is there any communication between the physics wala and you that they are communicating this one?
So that is what was the part of module 2 and module 3 were the part of
I think
what was
I
there?
The
think
mail
I
it
don't know
was
whether
told
we have
2, 3, and
access to
4.
the.
It was clearly told, no, 2, 3, and 4 are part of this. In the mail that you have received, the syllabus says that modules 2, 3, and 4
Yes,
will
No,
be
sir.
it is
covered,
5
right?
is also there.
Yes,
5
sir.
Yeah,
is
there
In
is
the
a
also there.
mail.
in the message, the physics wala told that the quiz question will be covered the module 2, 3, and 4. from the last class.
So that's
And
right. That's
module
clear
sir,
only, no? Then what is the
and sir
confusion
also
now?
told that from the computer architecture, from that module we start
Yeah.
the exam.
Yeah. So that's what I said, no? In one of the class, I said like whatever Professor Gopal who has taught computer architecture, from then to whatever I have taught, it will be the portion. That's what I said, if I remember correctly. That's what Ramya I said, right?
Sir.
So I think Biswajit sir, you have to, I mean, see whatever you have received is correct or see.
No,
Hello.
sir. That
Hello.
verbal communication is different, and this WhatsApp or mail communication is different.
No, that's what Ramya is saying. Like you got received,
Okay.
no? Like for all the 3 modules only it was
Yeah, that also
communicated.
I have listened. That also I have listened. That I remember. But there is some communication gap.
I mean, others are able to get it, right? Whatever, I didn't get this complaint from any other people.
Yes, but if you want, I'll forward you this yesterday WhatsApp communication.
No, I see from my end, I'm preparing. The questions that is being taught, I'm teaching to you, and whatever physics wala communicates, you better clarify with them. Okay. But I feel like whatever I'm communicating, the classes is they are able to understand. Okay. So you can talk to physics wala and get the clarifications in.
Yeah. That's why I asked whether they are communicating you. What are the chapters will be coming in this one? I'm not blaming on you.
Fine. No, I totally understand. I
This
totally
one
understand.
you. What are the chapters will become in these questions?
Fine. Okay, let's come to the class. It's like more than 10 minutes we are spending on other aspects. So,
Sir, I have a doubt.
Yeah, Jayvardhan.
Sir, it's regarding the topic only.
Yeah,
Like you mentioned there's a .v analog for like the PDK libraries.
.v is not analog. .v is Verilog model.
Yes, sir. Like I mean, like in analogous. My doubt is like, is there any other versions for like VHDL or SV versions for it?
For which one you are asking for? For the Verilog models that's provided in the PDK?
Yes, sir.
No, only the it will be provided. It will be you will be given with Verilog models only. You will not be given with any other models and all. Like usually it is Verilog model only. Whatever I have seen.
Yes, sir.
But why are you asking this? What is the point of this intention of this question?
Sir, like I just wanted to know if these models can be written in VHDL or SV also.
These models we are not writing. No, it is being given by the PDK. So if they are giving you that support of giving you in VHDL, they'll be able to give you. But these we are not writing it, right?
Yes, sir. Like any particular reason why they are only sticking to Verilog for that?
That's because that's the one that's commonly used in industry, right? So that's why. And when you are doing simulation, when you are doing our netlist based simulation, you are calling these Verilog models, correct?
Yes, sir.
And calling this Verilog model, if your netlist is already in Verilog, your netlist is already in Verilog, right?
Yes, sir.
And obviously, then your models also will be in Verilog, which will be easy for inferring and using it.
Yes, sir.
That's the point.
But like a certain aspect of the test bench can't be reused, like if we use other languages, right?
Correct. Then you will have to see replicate the test bench that you have written for RTL for this particular purpose.
Yes, sir. So it should be heavily modified or it should be like replaced with
It depends on if your test bench is Verilog, you need not modify it. If your test bench is not in Verilog in VHDL, then you have to write a test bench in Verilog for this.
Got it, sir. Thank you, sir.
Okay. Good doubt. Nice question.
Thank you, sir.
Yeah. Okay, so let's come back. So today I'll be covering a bit of this But the timing paths, whatever available, whatever paths are there, yeah, I'll stop sharing. I'll come to my tab. Jayvardhan, how was the questions? Did you attend the exam?
Yes, sir, I attended the exams. The questions are mostly like simple, sir, but one or two are moderates.
Okay. Okay. So, so your netlist that have netlist after doing synthesis, your netlist has what? Your netlist has some of the inputs. Your netlist has inputs. Your netlist has outputs. It has sequential cells. It has combinational cells. Correct? Yeah, I'm talking about netlist. Synthesized netlist. Correct?
Yes, sir.
Yeah. So now how do we say, how do we group the path that is there inside the netlist? What does grouping the path means? See, inside the netlist, if you see, you have flip-flops, multiple flip-flops, and you have multiple combinational logic that is connected to the flip-flop, correct? Like this. So these are flip-flops. And these are multiple combinational logics in between. These clouds are like combinational logics in between. So this is how your netlist look like on an imaginary, on a visually, if you wanted to see. This is how it looks like. There is flip-flop and there is combinational logic. There is, and that output of that combinational logic is again connected to another flip-flop, something like this. So how do you group this path is, first is you have input to flip-flop. This is one path where your chip is there. This is your chip. And you have inputs, you have outputs. So from the input, if you are passing some value, it goes to some combinational logic and it goes to a flip-flop. This is one path. Second path is you have output to flip-flop. That is, sorry. Sorry, flip-flop to output. That is, you have a flop, you have some combinational logic, then this flop sends out data to the output pin. So this is another part, correct? Then you have flop to flop, flip-flop to flip-flop. That is, after this it pass, the input comes to this flip-flop. From this flip-flop, it goes to another combinational circuit and then it sends to the data to the next flip-flop. So there is one more path, which is this path. So flip-flop to flip-flop, and then you have in to out, input to output. That is, you have an input pin directly it goes to some combinational logic, and then it comes out as output. Any doubt until now? I
No,
am
sir.
I am just telling what are the components inside the chip, and I'm grouping the paths that is there inside the chip with respect to the logical elements that is available. Any doubt? Fine.
No, sir.
Good. Now let's have the timing aspects seen. See how do we now we have grouped the
So,
path.
excuse me, sir. Sorry to disturb you.
Yeah, tell me.
This is Vineet.
Yeah, Vinny.
Sir, I know it's a silly doubt, but why is there a direct input to output pin?
This one?
Yes, sir.
There will be certain logic, there will be certain operations in the chip where there will not be any flip-flop involved, but rather only some combinationals will be involved, and then the output comes directly. So basically, this is a path that is generally not available, and that doesn't come into the timing aspects at all. I'm saying this input to output path.
Okay.
So this path is something where only computation is happening. There is no storage happening.
Okay.
Yeah.
Thank you,
Okay.
sir.
Yeah, fine. Good question. So now now we have grouped all these paths. Why I'm grouping this path is, what is the point of grouping is, it will be easy for me to estimate the timing for all these paths. If I'm able to get the timing for all these paths, then I'll be able to understand whether my chip is able to close at say 100 megahertz, whether my chip is able to work or not. Okay, you tell me which, so here flip-flop is there, here flip-flop is there, in this path here flip-flops are there. So wherever flip-flop is there, my clock is going to go there and clock the flop. So among these 1, 2, 3 paths, with which path is going to, which component of all these 3 is going to decide the frequency of my chip? You tell me which one. Whether input to flop path is going to design my frequency, or flop to output is going to design my frequency, or flop to flop is going to decide my frequency. Okay, so I'll give you further explanation so that it will be easy for you to answer. See, in a chip, right? In a chip, you will have lot of flip-flops, correct? You have lot of flip-flops, lot of combinational cells will be there. Okay, and we are grouping this, whatever is there inside the chip. This one we are grouping it. We are grouping it out here as into flip-flop, flop to output. There will be multiple flop to output. There will be multiple into flip-flop. There will be multiple flop to flop. There will be multiple into out. Okay. And in that, which is the most time consuming path among all these 4, which is going to be the most time consuming path, is going to be my critical path.
Flop to flop, sir.
Yeah, who was that?
Kuldeep, sir.
Kuldeep, good. Good. It's going to be flop to flop. Flop to flop is going to decide the frequency of the chip. So you will have multiple flip-flop to flip-flop path that will be there inside the design. In the design, which is going to be the longest path. Longest path, maybe you can say it as longest flop to flop path. So the longest path is called as the critical path. In your design, which is going to take lot of logic inside between two flip-flop, that's called the longest path. Now what I'll show you the timing report that I have generated, that I showed you yesterday also. Okay, in that you will be able to see the flop to flop path. How does it look like? How does that flop to flop path look like? But before we go into that, if you have not understood this, say you are not able to understand any aspect of this also, it is fine, I'll repeat, but please ask. Okay, so
So, is there any reference
So
book
then,
that we can follow according to the class? You can
is
suggest
there
anyone. Is
no, I
there any
didn't get
reference book?
reference
Is
book.
there any reference book or study material that we can follow with the class?
Maybe I'll have to see if there is anything there, any books are available, but whatever is there in the class, you are not able to understand.
Yeah, I'm able to understand, but it is taking quite time for connecting the dots, especially
I
because
see.
I have to.
Okay.
Yeah,
Yeah.
I'm lagging behind slowly, so that's why I was asking.
Okay, fine. I'll just
so
check if there is.
the
I'll just check
longest
and
chain
get back to you.
decides.
Yeah.
Okay, sir.
So the longest chain decides the frequency of the chip, I guess. Then.
Yeah. Come again. What do you see?
So the longest chain of flip-flops decides the frequency then.
Yes. Yes. That's what I said. The longest flop to flop path that is there, that is critical path that is going to decide the frequency of the chip. Okay, so let me show you how does a flop to flop path look like. Okay. You're able to see my screen, right?
Yes, sir.
Oh. So this is the synthesis report. Okay. After synthesis, you will be able to analyze all these things in the reports that is dumped, which I was telling you yesterday, right? There will be some set of reports. Through this, we'll be able to analyze whether my design is able to meet the required frequency, all those things. So if you see here, I have 4 reports, which is flop to flop, into flop, into output, and flop to output for this up-down counter. So let us see one by one. Let us see whether if there is any input to output path available for this particular up-down counter that we have. If there is any direct input to output path that is available, we'll see that if there is anything. So here, if you see, it says no paths. There is no direct input to output path available. Okay, for this design. Okay, then let's see if there is any input to flop path available. I to F is available. Yeah, if you see, there is one flop there is available, which says the start point. So I wanted you to look into this very carefully, because we are going to see what is this report is telling us. So it will take time normally it will take time to understand, but please pay attention. So in this report, these are some headers these are some headers that are common things when the report is dumped. So from here you have to see what is the start point and what is the end point. So start point is, what is it saying? Up or down. Okay. Up or down is what? It is an input pin. Where do you see? Where do you take the reference from? You can see it in the RTL for this up-down counter. So in the RTL, what did you mention? Your inputs are clock, reset, up or down. Your output is count. Okay. Now in this up-down counter, the into flop path, you see the start point is an input pin up or down, which is an input pin. And the end point is count reg 3. Count reg 3, reg 3 is a flop. Okay. It says this is a rising edge triggered flip-flop clocked by the pin clock. Okay. And your up down is also clocked by the pin clock. So that means for this particular frequency, the input is fed. Now, if you come down here, this is the timing path that it is showing. Okay. So I'll tell you from line number 33 to line number 71. Okay. Is one particular one path's report, one timing path report for input to flip-flop. Input is up or down pin and flip-flop is count reg 3. That means, see, what does this mean is my input is passed from this up or down pin in. Okay. Then it is going to an inverter, input to an inverter. Okay. Then INV0D1 is an inverter. In that, Zn is the I is the input of the inverter, Zn is the output of the inverter. Then from the output of the inverter, it is going to a NAND gate input A2. And from the NAND gate's output Zn, it is going to again an inverter. Again, it is going to an AND OR invert. Again, it is going to OR and invert. Then it is going to a NAND gate and it is going to another NAND gate. Then the output of this NAND gate is getting connected to the D pin of the D flip-flop. Now it has arrived to a D flip-flop. Okay. It started from an input pin, went through a set of combinational cells. Okay. These are the set of combinational cells and it is getting stored in a D flip-flop. Any doubt until now?
So how do you know there is only one path, one input to flip-flop path?
There will be multiple paths. Okay. This is one of the path.
Okay.
Yeah. And you will have the next path here. If you see at line number 74, this is the next path, which starts from up or down same pin and goes to count reg 2. Here it goes to count reg 3 previously. Now in the second path, it goes to count reg 2, starting from the same input pin.
Okay, sir.
Got it? So, yeah. So the top path is the most critical path in this particular into flop. Whichever is the longest path in into flop will come in the top. Then you will have subsequent paths here, which is not to be a critical, but it is going to take less time than that. Okay. To see what justify whatever I have said you now. See here we have applied the clock. Okay, come to this. Now here the up or down is there. No, up or down pin is getting connected to the inverter. If you see, just look into this value alone. Okay. There is an default input external delay. Okay. That is 0.50 nanosecond. Okay. Then you have this inverter. Line number 39. You have this inverter and there is a delay of 0.24 nanosecond. This 0.24 nanosecond is picked up from the standard cell library of this inverter. Okay. 0.24 nanosecond plus 0.50 nanosecond is going to be 0.74 nanosecond. Now the timing is getting added. Okay. Then you have your net delay. If you see here net, that is getting converted. The output of the inverter is getting connected to the input of a NAND gate through a net. This net, if you see, there is no delay accounted here because there is no actual net is available during synthesis, right? So there is no net delay. Then you have your NAND gate. It is going to a NAND gate and it is coming out of the Zn pin of the NAND gate. And if you see here, the NAND gate takes 0.16 nanosecond. Okay. So 0.24 plus 0.16, sorry, 0.74 plus 0.16 is going to be 0.90. Okay. So like this, it goes on. Goes on. And finally, your data that is passed through this up or down pin, and the data goes through this all combinational cells and comes to this flip-flop and gets stored here. And your data is arriving at this particular time, that is 1.76 nanosecond it is coming. So, but you are providing 2 nanosecond as the clock time period. At your constraints, you have provided 2 nanosecond. In this 2 nanosecond, 1.76 nanosecond is consumed by the entire path, entire cell that is there. And there is a minimal library setup time that is also there, which is a default thing, which is going to be 0.18. Okay. So totally 0.18 plus 1.76 is going to be 1.82 nanosecond. Okay. 1.82, sorry.
Sorry, it's a 2 minus 0.18, right, sir?
Sorry. So totally you have 2 nanosecond as a time period. In that, library setup time goes as 0.18. So you have 2 minus 0.18. So your available time is only 1.82. And your data is arriving at 1.16. So 1.82 is the only available time for you. In that 1.76, if you subtract it, you will have 0.05 is your slack. Is that clear?
Sir,
Yeah.
I have a doubt.
Yeah, Anirudh.
Sir, the clock CLK rise age 2 nanoseconds is given, right, sir?
Yeah.
Where is that information given, sir? In that
This is
slow
provided.
like
This is provided the constraint.
Okay, sir. Okay.
In constraints, you are giving the time period.
Okay, sir. Got it, sir.
So that determines. Suppose you have given, say again, let's take it here itself, Anirudh. Now, instead of 2 nanosecond, if you have given 1 nanosecond.
Yeah, sir.
Okay, so what would have happened is 1 nanosecond. Already library setup time is a default number. Okay, so 1 minus 0.18 will be 0.82, correct?
Yes, sir.
So instead of this 1.82, you will have only 0.82. And your arrival time is 1.76. So 1.76 and you have 0.82, you will have a negative slack, correct?
Yes, sir.
That means whatever you have specified in your timing constraint it is going to be, it is not enough for your design to meet.
So slack is not met.
So slack is not met and it is negative. Then you will have to increase the time period and see.
Okay, sir. Got
This is how you are going to estimate the timing. That's what yesterday somebody was asking. No, area I can estimate. How can I estimate the timing? Somebody was asking. No.
Yes, sir.
Yeah. So this is how you will be estimate the timing. Like what is the maximum frequency your design can run. So this is, by the way, whatever we are seeing right
Sir,
now.
like there will be, sorry.
Yeah, tell me, Lakshmikant.
Sir, like there will be any data that this particular gate will be taking this much time, particular time. So based on that only we can predict that this is the time which I have set. I have to set.
Yeah, this is what this is the process of doing it, Lakshmikant. So you will have to give some random value for random timing value for your in the constraint, and you have to run it first.
Okay.
Yeah, and then only you'll be able to see like what time it is closing, at what particular time period it's closing.
Okay.
Sir, I have a
Like
question
trial
regarding
and error
library
we have
setup time.
Sorry, Lakshmikant, you have something else? Yeah, okay. Biswajit, you were saying something.
Yeah, sir, regarding library setup time, this depends on the PDK, that version or foundry of the PDK, or how it is happened.
Yes, library setup time is picked up from the PDK. Okay. Also, all the other values, all the other delay values you see here, 0.10, 0.21, 0.23, this is also picked up from the standard cell library PDK, from the standard cell library timing values that is there for each cells.
So what
Okay.
are those F and R in the path column after the incremental time you have either F
Okay.
or R, right? So is it
Good question. Good question. So this is called as fall time and rise time. Okay, which will come back. Yeah,
okay.
which will come back once when we are coming to this topic. Okay.
Yeah.
Yeah.
I also had one more question. Maybe it's a
Yeah.
dumb question, but
Yeah.
so we are considering on the timing constraint, right? But we also need to consider resistance, capacitance, and all the other things also, right? Because in the standard cell for each of them, it has a specific capacitance and all those other parameters, right? So why only timing is a constraint, right? I mean, power could be a constraint, right? So in the synthesis process, don't we need to tell that also, that this is my power constraint and synthesis for this power constraint, right? Something like that.
Yeah. Somebody was. I mean, yesterday you were only asking about the telling a doubt for this UPF, right? UPF. Somebody
No,
was
that's
asking. Someone else was asking about UPF. UPF is another. So like we have timing constraints. We have timing constraints as SDC format, right? Synopsis design constraints, SDC. Similarly, you have for power, you have unified power format. UPF format is there.
okay.
Where you will consider what is the power requirement, all those things you will be talking there.
Okay.
So, like you said, you were asking about the capacitance and resistance and all, right? Here in this timing report itself, you could see this cap.
Yeah.
So this is the 0.03 microfarad is the capacitance that is there for this particular net. That's what it is picking up. Okay. Using all these capacitance value, it will be able to tell you the total power that will be required for this particular design, which we will also see that.
Okay, thanks.
Okay. By the way, whatever right now we are discussing is an input to output path, input to flop path. Okay, which is not flop to flop. This is not going to decide the frequency of the chip. Your frequency of the chip will be defined by the flop to flop path, not by into flop or flop to output or anything. It is going to be flop to flop path, which is going to decide the frequency of the chip. We'll have a look into the flop to flop path once. Yeah, Marufa, you have some doubt? Marufa, I'm not able to hear you properly. Come again once again. I'll try to hear. Marufa, you're muted, huh?
Sir, what will be the impact of setup time violation here?
What is that?
My voice is clear now.
Marufa, your voice is not clear, but I have seen your chat. What is U27 means? We'll go to that report. This one? Yeah, this is U27 is the instance name for this NAND gate. Like here, if you see, right, for this D flip-flop, this count reg 3 is the instance name. Similarly, for this NAND gate, U21 is the instance name. Yeah. Instance name in the netlist you have seen, no? Say, for example, you take this NAND gate. I'm opening the netlist. Okay. So if you see here, this NAND gate U21 is there, no? This U21. This is the instance name. Got it?
Yes.
Yeah.
Sir, if I may ask,
1 minute, Vineet. Somebody was, Kuldeep was asking something. I'll finish him and come back.
yes, sir. Okay.
Yeah, Kuldeep,
Sir,
tell
I
me.
was asking what will be the impact of setup time violation, as in if the clock edge arrives later.
That I was telling to someone, I think I was telling to Jayvardhan or someone. So, see this, this timing path I was showing, right? I am specifying the clock as 2 nanosecond and running the synthesis. 2 nanosecond, I'm specifying it in the constraint file and running the synthesis, and I'm seeing that I'm able to meet the slack here. The timing I'm able to meet. Instead of this 2 nanosecond, if I'm giving it as 1 nanosecond, assume if I'm giving as 1 nanosecond. So from this 1 nanosecond, I will have to subtract this 0.18 and I'll have 1 minus 0.18, it will be 0.82. So I have only, instead of this 1.82, will have only 0.82 as the available time. But here, if you see, my data is arriving at 1.76 nanosecond, and I am what the available time for me, the required time is there. It will be is only 0.182. Okay, when I subtract 1.76 with this 0.182, I will get a negative value here. Correct, at the slack.
Yes, sir.
So that means I am my setup is violating now.
Yeah, okay, sir. Got it.
Got it? So I
Yes,
have not introduced this setup time, hold time and all until now, because if I introduce that, then I will have to explain everything and the other people will get confused. That's why I'm just minimally I'm telling it and moving on.
Sorry. Okay, sir.
No issues, no issues. Yeah,
Sir,
tell me,
next to
Vineet.
the
Vineet,
capacitor, the trans is there. That
come
is
on.
for transistor. Next to the capacitor, just a little go up, a trans.
Yeah, that
That
is for
transistor.
transitioning time.
Okay.
Yeah.
And fan out, what is this fan out?
Fan
The
out
input
is,
capacitor.
fan out is, there are two aspects. There are two things, fan in and fan out. Fan in where all the wires are getting converged to one particular pin is fan in. If there is one particular, for example, this up or down is what? Up or down is what? It is
Oh,
a
scattering you mean to say. In the boss, scattering from one point to multiple points.
yeah. So up or down is a pin, okay, and that pin is getting connected to a net. Net is something, a wire, and from this up or down pin there are 4 fan outs that is coming out, and in that 4 fan out, one of the fan out is getting connected to this inverter, okay.
Yes,
And from this inverter the output is the Zn, and if you see the output of this inverter is going connected to a net, and this has 5 fan outs. And among that 5, one is getting connected to the input of the NAND gate, one input of the NAND gate, like that. Got it?
Got it, sir. Got it, sir.
Okay. Vineet?
Good morning, sir. Is there any chance for the data arrival time and the data required time to be the same?
Yeah, it might happen. There is nothing like it cannot happen and all.
Sir, then in that case, what will happen, sir?
Slack will be 0.
Yes, sir. I mean, like slack will be 0, but not able to put it in the right words.
No, what are you trying to say? I'm also not getting.
I mean, like yeah.
You mean to
For
say that
example,
that's a in between state, like it can work or not work, something like that you're
yeah,
trying to
yes,
say?
sir. Yes, sir. Yes, sir.
Okay. Okay, I could get that thing, but that is not the way it will be happening, Vineet. It is like what all values it is coming here, right? These are picked up from the standard cell library, and these are characterized the way that it should work. It cannot happen that way.
Okay, okay, sir.
Yeah. Okay, so that's all. Let's go to the flop to flop path and analyze that. So into flop is understood, right? Let's now go to flop to flop path, which is the important path, which for all the designs you see. Okay, for all the design, whenever you are trying to do synthesis, you will have to see only flop to flop path. So if you see here, the start point is line number 21, which is a flop, count reg 0. The end point is a flop, which is count reg 3. Okay. Let me open the netlist and give you this view. Okay. See, count reg 2, count reg 1, count reg 3, count reg 0 are the flops. Okay. And these many combinational cells are there. Now we are finding the path that is between one flop to another flop. Between among these 4 flip-flop, which all paths are there, we are going to find out that. Sorry. So here the start point is count reg 0 and the end point is count reg 3. Okay. That is count reg 0 and count reg 3. Between these two, there are some combinational cells present, and that path only we are going to analyze. Clear? Clear?
Yes, sir.
Okay. Now, if you see this, so your start point is your count reg 0. So this is a clock pin of this flip-flop, and this is the Q pin of the flip-flop. So when you're doing flop to flop, means what? The first flip-flop is there, no? This is the first flip-flop. And so this is the source flip-flop. Let's say it this way. This is the source flip-flop. The start point, this is the source flip-flop. And this is the destinational flip-flop is your end point. So the path starts from the Q pin of the source flip-flop. Okay, the path starts from the output of the source flip-flop and the path ends at the D input of the destinational flip-flop. It starts from Q and it ends at D of the other flip-flop. So the output of the flip-flop Q is taking 0.66 nanosecond, okay, which is accounted here. Then it is going to a net and it is going to an XOR gate. In XOR gate, it is taking 0.57 nanosecond timing, and 0.66 plus 0.57 is 1.23. Similarly, then it is going to an inverter, it is going to a NOR gate, it is going to a NAND gate. Again, it is going to a NAND gate, and the output of the NAND gate is going to this count reg 3 flip-flops D input, and the total data arrival time is going to be 1.83 nanosecond. And your whatever the time period you have specified is 2 nanosecond. So your library setup time here is 0.17. So 2 minus 0.17 is 1.83. So 1.383 is your required time, which is going to be your required time. And the data arrival time is also 1.83. Though, so the slack is met here. Vineet was asking this question, is it? Like if what data arrival time and required time are same. Was that Vineet?
Yes, sir. Yes, sir.
See here what is happening. It's the same thing that you asked is coming here. So if you so what I'm trying to say is, so this is the most critical path. Critical path is the longest path among the designs. So if you see the next path is at line number 69. The start point is count reg 1 and the end point is count reg 2. Okay. Here, if you see, there is some positive slack available. That means this path is not critical. The critical path, if you see here, there is no slack available at all. Got it? Any doubts? Any doubt?
So this library setup time, right? What does it actually signify? I mean, you can understand the other things. It's a delay from one hop to other hop, right? But what does it signify, that library setup time?
Library setup time signifies that how many cells, how many combinational cells are there in between this flop to flop. Okay. And also this flop was also accounted. So there is a minimal setup time required for this flop to work. Okay. If I am passing one input to the D pin of this flip flop, there is a minimal time for this flop to wake up and, oh, I have got an input. Now I have to pass this value to the Q pin of my flip flop. Okay. That is a minimal setup time required for this flop to work. Similarly, there is a minimum setup time that is for this NAND gate to work, NOR gate to work, inverter to work, XOR to work. So all this minimum setup time is accumulated and given as library setup time.
Okay.
Good question, Arun. I think you're observing really good. I thought of skipping this actually. Good. Okay. So I hope everybody has understood what is the timing path signifies. So to give you more insight, okay, to give you more realization, what I'll do is I'll run a synthesis. Okay. I'll run a synthesis by changing the constraints. Do you guys want me to do that?
Yes, sir.
Yes, sir.
Okay. So I'm changing the constraint and changing the time period to what? What do you want? What do you want me to put instead of 2? Previously it is 2. Okay. What do you want me to put the time period?
You can put 1 or 3, sir.
Let's see. Let's put 1. Okay. 3 anyway, it is going to close. I'm changing the duty cycle also. Okay. Okay, before that, let me preserve the old reports. No reports to reports old. Well, synthesis is happening. See here, during synthesis, there are certain optimization that usually happens. These are the steps, okay, which shows like I'm optimizing. These are like some delay optimization happening. So leakage power optimization is happening. Okay. Yeah, I think the synthesis is done. Yeah, that's done. Now let's look into the reports. So which report you guys want me to see?
Flop to flop.
Good. I'm opening the flop to flop report. See, this is the topmost critical path, count edge 0 to count edge 2, start point and end point. If you see here, you have given the clock as 1 nanosecond, correct? And it is giving a negative slack. Biswajit, you are able to understand?
Yes, sir.
Okay. Now I am going to point out someone. Okay. And I am going to ask the question now. Okay. Surya Pratap, can you unmute your mic? Surya Pratap Sarangi. Okay, Mayappan S, can you unmute your mic? Nikita? Nikita, can you unmute your mic? Jiben Roy?
Yes, sir.
Jiben Roy, can you explain what is this negative slack here implies to?
So negative slack is sir, actually my English is very weak. So
No issues.
please
I'm
forgive.
able to. That's not a problem. I wanted you to tell me what you have understood only. I'm not caring about your English.
Sir, actually, negative timing is library uh, uh, data report time and library time is positive, uh, positive.
Okay, if it is positive, then what does that mean?
Man, sir, data report time and data arrival time difference is positive.
So what does that mean? If it is positive, what does that mean?
Sir, that is sir, that is sir, negative timing. There is some, yeah, that means my design is workable.
Okay, your design is going to meet that particular timing. That's the implication, correct?
Yes, sir. Yes, sir. Yes, sir.
Fine. Okay, good. Good, Jivan. Okay, so today's class we were looking into the different timing paths that is there inside your design, and we were trying to analyze it. We will go more deeper into this in the upcoming classes. My request will be to please revisit all the recordings and come back, because we are right now entering into more detailedly we are entering, and it will be very difficult for you to understand. If you think that you may learn it later, it is not going to happen. It will be very difficult for you to understand. Okay, that's all from my side. Any doubts, any other clarifications you have?
One
Sir,
question.
Ramya, yeah, I'm not able to get you.
One question is, not about that. That means we are study about the synthesis,
Yeah.
synthesis part. So for that reference, which book we can use?
Which book for synthesis?
Yes, more that one book you said more and more. That books
No,
discuss
no.
about the
See,
RPA.
See the Maurice Mano book is there. No, that is for the people who have not who are not gone through the fundamentals, who are not studied digital electronics. For them only, we have suggested books. Okay. Whatever I am teaching you will not be there in any of the books. Okay, this is out of my experience, out of my whatever I have learned through my experience. I am teaching it. I am a working professional. I am not a academic person.
Okay, sir. Thank you. I got it. It's real time application, I say.
Yeah. So if you wanted some books, then I will have to search for some books. What is there, where it is there, I have to tell you. I will have to see if there is anything there. I will see if there is anything is there. If I'm not giving means, if I'm not suggesting means, that please understand to that you will have to look into my class only and have to understand.
Okay, sir.
Sir, Foundry, does they provide any product documentation? However, they have designed. If you go for any software product, they used to provide the product documentation details. In Foundry,
Foundry
such
will
kind
not give you any product documentation. Foundry will give you documentation related to the PDK that it is giving regarding the library file, regarding the Verilog model, all those things. For those only it will give you the documentation. Foundry will not be able to give you a product that you wanted to manufacture. How will that Foundry will be able
no,
to?
not that product. This, they are a library only. This library documentation.
So that's a library documentation that's regarding to the PDK.
Yes. That one I am talking about.
Sir, this data
That is
required time.
available for public or not? If it is old product, archived product, something.
Sir,
Yes.
please don't mention as a product, sir. It is going to be process development kit, which is PDK that is given by the Foundry. Now you asked me a question with respect to that. Product is something that we are going to give it to the fab and manufacture it.
Okay, that PDK, and if some PDK is old PDK, means which is no longer being used, which is that may be developed 10 years before. Such type of PDKs, documentation is available
Yeah.
would be
So
market.
yeah,
You can also
if no, all the PDKs are bound to NDA. Okay. But there are some open source PDKs available on internet. You can search for open source PDK like Skywater 130 nanometer is there, which is open source and it is available free only. You can download that Skywater 130 nanometer, and you can look into that. There will be documentation, dot lib, everything will be there.
What is a SkyWater, sir?
SkyWater, SKYWATER, SkyWater 130 nanometer.
I just sent you that link for the Global Foundries one, right? So they have a open source PDK.
Yeah, I think Arun has sent some link. You can refer to that also.
Yeah, thank you.
Lakshmikant, you were asking something?
Sir, this data required time will be given by us only, sir.
Data required time,
Yeah.
this one?
So data arrival time is that total calculation of the gates which is running.
Correct.
So,
Data required time is this is the time that we will give. Clock is this clock. This one we will give. And
Yes, sir.
there is a default library setup time which will be consumed, okay, which is 0.14 for this particular design. So your total required time now reduces to 1 minus 0.14, which is going to be 0.86. That is your total required time that you have right now in your hand.
Okay, after that library setup, the remaining time will be like
After the library setup, the remaining time will be left over to you.
Yes, sir. And with respect to this library setup time, like you told me that you told us regarding that.
Yeah,
each and
I was
every
telling.
each and every gate will be having an
I was telling
particular time
like
required.
you want me to explain that?
Yeah, sir.
Okay.
Because
So I was telling for every gate that you have in this path, okay, you have NAND gate, inverter, AND or invert, XNOR, you have a D flip-flop. For every gate, there is a minimal setup time required for the gate to work, for the gate to wake up. Okay. When if all the gates are switched off, when there is power on, when you are powering it on, there will be minimum time for the gate to wake up and try to get the inputs after that only. So that particular time is there, that waking up time is there, that is called a setup time for that each gates. That is a setup time for each gates, and those time is calculated, and that is only is given as library setup time.
So it is a total time of
total time,
like considering all the gates.
Total time. Yes.
Okay. So this will be given by the PDK itself, right, sir?
This value is picked up from the PDK only. This value is picked like you have these values, right? These delay values.
Yes, sir.
These are picked up from the library only, right? Similarly, this is also picked up from the library. This will not change. This is something that this will not change. I mean to say that this is something that is going to definitely consume. It is not going to reduce and all. But if you are going to, for example, if you are going to optimize this path in your design, in your RTL, if you are going to optimize this path by removing certain logic inside your RTL, then this path will shrink again. This path will not be this much big, it will shrink.
Yes, sir.
At that time, these delays will go off. These delays will go off because these cells will not be there.
Understood, sir.
Okay. Any doubts? Any other doubts? We are off time. Okay. Prithvik is asking, sir, in a processor, we have different hardware blocks and each of them will get different slacks, whether either positive or negative. How we manage those things to get correct information at the right time? Okay. Prithvik, shall we answer this in the next class? You keep this question. This is a very good question you have asked. We'll because this will take some 10 minutes for me to answer. Okay.
Okay, sir. Fine.
Okay, just remind me in the next class. Okay.
Okay, sir.
Good question.
Sir, one small this one, sir.
Yeah, Lakshmi.
Like yesterday, I couldn't attend the test quiz, sir. So is it possible that I will get a chance like today or tomorrow?
I don't know, Lakshmi. This you have to check with physics wala.
Yeah, sir. I tried calling them, but they did not reply.
I would always say, please abide to the test timing somehow because they are
Yes, sir,
anyway
because
giving you.
due to meeting, yeah.
Okay. I don't know because see, I don't know how do I comment because even I'm a working professional. I understand, I totally understand your thing.
Yes.
So, but I don't know what to give an answer for that. We cannot have a retest and all, right? Because once the questions are out, we cannot have a retest. It is not justified also for other participants if you are giving a separate time for you with the same set of questions, correct?
Understood.
Mm. Hello everyone, good evening.
Good evening, sir.
Good
evening, sir.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Good evening, everyone. Good evening. Okay, so before starting the class, I hope everybody has got your marks for the exam that you have given. Have you got?
Yes, sir.
Yeah.
Okay.
Yes.
How was it? Like, is it satisfactory? Whatever you expected, that was the mark, or that is something that you didn't expect? Because I have got all your, yeah, I have got your mark. I was also shared. It was given to me first, and then it was asked to me that whether this could be shared or not. Then only I approved to share it. See, for me, the feedback that I wanted to give you is these questions were actually not extremely easy or not extremely tough. It had most of them are were like medium component only. The questions were not tough and all. The only factor was the time and the time required for to answer the questions. And to the effort that we took for teaching, as in myself, Gopal or Uma, the amount of effort that we took, I feel that this is something that everybody should have answered. Everybody should have got more than 10 points out of 15. But the one who have scored below 10, I request please pay attention hereafter to the classes. It is not going to work if you are going to see only the recordings, because the recording will have its own leverage for you. Yeah, I understand. But on during the classes, I have seen whoever have scored good. Whoever have scored good, whoever have scored more than 11 out of, few people have got 15 out of 15 also. Whoever have scored, I see that they were interacting with me during the classes. They were able to talk to me. They were able to clarify their doubts. So for those people only were able to score good marks, decent marks, I would say. So whoever has scored less than 10, this is not going to work out. So please pay attention. Any doubts during the class is a freedom for you to ask. Okay. During recording, it's not a freedom for you. So yeah, that's all I wanted to say. Any thoughts? Okay, fine. Let me get started. Anyway, congratulations for the one who have scored very good marks. I have seen few people wanted to name them actually. I think that is the best way to encourage them. I would name the one who have scored about 12, and up to 15. So Surya Pratap Sarangi is there. Is there in the class? Okay. Surya Pratap Sarangi scored 15. Pavitran is there. People are yet to join, is it? Okay, only 32 has joined.
Hello, sir.
Yeah,
Yeah,
Pavitran.
Pavitram. Sir, am I audible?
Yeah, you're
Yeah,
audible.
you're audible.
And
And
I'm
I'm
getting
getting
echo.
echo.
You're joined
You're
with some
joined with
other
some
audios
other
also.
also. Yes, sir.
I think you
I
should
think you should
mute the
mute the
voice.
voice. Okay, sir.
Okay, so Pavitran has scored 15. Good, Pavitran. Congratulations. And then you have Tamanna Verma. Tamanna Verma is here. Tamanna Verma is yet to join. Okay. Tamanna has scored 12. Anirudh, I think he will be here. Anirudh, you are there?
Yes, sir.
Yeah, Anirudh, good. You have scored 13. Congratulations.
Thank
What
you, sir.
went wrong, Anirudh, for you?
Sir, I basically made a very simple mistake, sir. That Mealy More question, I don't know, somehow I got confused, and due to the time constraint, I got the wrong one.
Fine. Okay. Okay, good. Good. Maybe keep this energy going on, because hereafter whatever I'm going to teach is going to be a bit complicated also. So yeah, good, Anirudh.
Thank you, sir.
Then after Anirudh, Likith is here. Likith is yet to join. Darshan is here. Yeah, I see Darshan is here. Darshan, congratulations. You also scored, how much? Yeah, 12. And then Akinapalli Pradvik scored for 14. Kuldeep Bharadwaj, 12. Rohan is here?
Yes, sir.
Yeah, Rohan, you scored 12. What went wrong, Rohan?
Nothing, sir. I was in a hurry. I was in the middle of an engagement function. I just dropped by to write the test and then walked off.
Oh, by bad. Okay. Okay, then Jayvardhan, you are here?
Yes, sir.
What went wrong, Jayvardhan? You scored 12. What went wrong?
Some of the questions I was not certain, sir, so I just clicked them due to lack of time. Yes, sir.
Okay. Raghu Chandra is there? Raghu Chandra? Raghu Chandra is yet to join, I think. Okay. And at last, Nikita Udoshi. Nikita is there, no?
Yes, sir.
Yeah, Nikita. Nikita, very good. You scored 15 out of 15.
Thank you, sir. I mean, actually, I was in a hurry too. I was traveling at that time. I was on my vacation.
Okay. You are a student or you're a working professional?
I'm a student, so I'm in final year of engineering.
Okay. Good. Okay.
Thank
Congratulations for everyone. For the one who have scored little less also. It's okay. I would request everyone to pay more attention to the classes. I have read out the marks for the one who have performed good, because I have to acknowledge them. I have to appreciate them. That is a duty of every teacher. So, and I also would like to wanted to appreciate everyone hereafter who is going to get good marks. Okay. So yeah, all the best for the upcoming exams. Let's get started with the classes.
Excuse me, sir.
Hello. Yeah, Dhanush.
Sir, could you repeat my marks because like I've joined just now.
Dhanush, I have been telling the marks for the people who have scored above 12.
Okay.
You know your mark?
No, sir. That is the reason I'm asking.
Was it not shared to you?
No, sir.
I think it was shared to everyone. Was it not shared to everyone?
Like I didn't know like where it was shared.
That I don't know, but Nikita, how was it shared to you?
Sir, actually, I was not knowing my marks because even I did not know how to check it.
We
Oh.
received an email, sir, with the report of marks to everyone. I think all.
Oh, then I
Maybe.
guess you have to check your email then.
Okay.
Anyway, Dhanush, since you asked your mark, you scored. Dhanush Irkuvajlu is you scored 6 mark out of 15.
Okay, sir. Yeah, thank you.
Satya sir, you were not there in the last class?
Yes, sir. I had some personal emergency. My mother was unwell actually on that day. I couldn't join, but I have completely gone through that recording. And
Okay.
also, I have one question. With your permission, I can ask now or maybe later also.
Yeah, we can ask now, sir. Like I wanted to brush up the last week topic anyway.
So when we define the chip frequency, right, we considered the critical path, right, which is from, I think, from flop to flop, right? That's what it's been discussed. Now, there are different paths in that, right? Input to flip flop, flop to flop, flop to output. Multiple paths were there, right?
Yeah.
And there is a direct input to output as well. So, why? See, any calculation or any flow, a complete flow, doesn't involve. Does it involves all these four paths? Is it not the combination of all these four paths? Why did we select only this flop to flop path only? That was little unclear for me actually.
Okay, so
I'm thinking from the perspective, it should be if some calculation or some flow involves all these four, right, 4 paths, then it should be a combination. The frequency should be a combination of all these 4 rather than considering only one flop to flop.
Okay, so you are able to see my screen, sir?
Yes, sir. Yes.
So, so the first one is input to flop. Second one is flop to flop. Third one is output to flop. Fourth one is in to out. Sir, we are not we are considering flop to flop for a reason. As you said, like we are anyway considering all the paths, and we will see whether the timing is met in all the paths. But flop to flop is the one that is more critical one. That's why we are concentrating on that. Because if you see flop to flop means what? So you have a flip flop, D input, Q output, clock. Then you have combinational logic. Then you have D input, Q output, clock. So this is the flop to flop path, correct, sir?
Yes, sir.
So here, if you see, what all aspects that is coming into picture is this flip flop has to launch the data from here. Whatever it has stored here in this flip flop, it has to launch the data from here. It has to pass through inside this combinational logic. So whenever the data is launched from here, that means what? That means in the positive edge of the clock, the data is launched. Say flip-flop 1, D1, data is launched. And then it goes inside this combinational circuit. Then it goes to this next flip-flop where the data is captured. So then you will receive the data in the next clock pulse at D2. Output to flop is like, this is flop to output. I'm sorry. Flop to output is where you have one flip-flop and the Q output is going to a combinational circuit, then it is going to an output pin, primary output pin. Then into I2O doesn't involve any flop. So here only if you see 2 flip-flops are involved at a time, and the complexity of meeting the timing here is more compared to other paths. You got understood, sir?
Yes.
So that is why we consider flop to flop is the more primary thing, and meeting it is also meeting the timing between flop to flop is the most critical part of static timing analysis that we call as an STA during the chip implementation process, and there will be separate engineers working for this to meet the timing. Other paths and all, meeting the timing is trivial. Like it will be easy to meet, but flop to flop, if I am trying to meet the timing,
For this F2F, right? Let us say that Q pin you are connected. There will be some input to F also will be there, right? And after this, F2 output also will be there. Let us say, right? So, I mean, I understand, like, we'll consider factorize more of this F2F only. But if we add up all those things also, that right, why don't we add up all those things and consider that as a chip frequency instead of considering only this one, is my question.
Can anyone answer? Can anyone answer for this question from Satya? Did you guys get the question from Satya? He's asking if we are, so there will be lot of flop to flop paths. Say from after here also there will be some paths. Before this flop also there will be certain paths. He's considering why we are considering only one path, not the entire path. That is your question.
Yes, sir. Yes, sir.
Sir, because it is the critical path.
Exactly. That's the point. Good, Anirudh. Because we will have a lot of path. I think if you have seen the synthesis report, Satya, so
Yes,
you,
yes.
yeah. So in synthesis report, the timing report, if you see, we will have multiple start point and end points.
That's correct.
So in the topmost path that you get in synthesis is the critical path, which is the longest path.
Right.
That will require the more timing to close. More timing means what? In more timing means what? Within one clock cycle, one period, this the functionality here should happen. Okay, so let me pull off the timing report and show it to you. You're able to see my screen?
Yes, sir.
So this is the flop to flop report. So as you can see at line number 21 and 23, it is saying the start point and end point. So between the start point and end point, you have multiple combinational logic. Okay.
Yes.
And we have given clock the constraint in the constraint we have given as 1 nanosecond. So the data arrival time is around, it is 1.26. The data required time you have only 0.86. So your slack is minus 0.39. I think
It's violated.
Violated, but let me pick up the report that is closing.
Sir, ideal slack should be 0, right?
Flop to flop. That is flop to flop.
Yeah. So we have run it for 1 nanosecond, and that's why we are getting the slack as negative. So if we have run, so this is the report that I'm going to show you that we have run for 2 nanosecond. Then you will have the timing closed report. So here, if you see, I have run it for 2 nanosecond. and your slack is met, that is your data required time and data arrival time is the same. So that's why your slack is 0. So if you see the next path, if you see you have a slack of 0.21.
Right.
So this is the next you were asking, no sir, before that flop and after that flop, whatever paths are there.
Correct.
So this is one of the path like that.
Right.
Now what, for the ease of computation, for ease of understanding how much timing it is taking, that for that only, first of all, we have splitted the entire design into input to flop, flop to flop, output to flop to output, input to output. We have what we have just divide and conquer approach only we are doing. The entire design we are dividing it and checking whether all the paths are met.
Right.
In the flop to flop, we are seeing whether all the all the timing is met for the critical path.
Okay.
So for all the paths, you will be able to see start point and end point. You will be able to see.
Okay.
So if you are able, but mostly we will not go and check all the paths because it's understood only if the critical path is timing is met. For all the other paths, it will be met only.
Okay.
The tool will give you the topmost critical path only when doing synthesis.
Okay. So we will do most of the optimization also in this critical path only, adjustments or whatever, right?
Yeah. What do you mean by optimization?
Just know before this, just before you have mentioned, right? If there is any variations, for example, it was not met, right? You will do
So what
some
we will do? What we will do if suppose, okay, now if I am saying for 2 nanoseconds it has met, okay. For 1 nanosecond I have run the design. And I see that my timing is not closing, okay. I see that my timing is giving us minus 0.39, okay. Now what should I do in this for me to meet for 1 nanosecond? Guys, this is an open question to everyone.
Do we need to revisit the combinatorial logic and as well as the whatever the fan outs that are happening there, right, between the devices, if it's optimal or not, right? Between those, I'm just thinking.
Yeah, I understand, like you are talking from top of your mind, but wanted to know, like, what is, if I wanted to meet for 1 nanosecond, what should happen here so that I can meet it my design for 1 nanosecond? This question is for everyone. This is a good analysis that we are doing. Nikita, what we have to do? Any idea?
Sir, maybe we have to add or remove any buffers.
How adding buffer we will be able to meet? Adding buffer will have its own delay, right? Its own time, rise time and fall time delay will be there.
Yes, sir.
Okay.
Maybe we can simplify the critical path, sir. Like simplify the logic so that it remains minimum functionable.
Good. So if we are able to reduce the minimize the logic at your design level, not at netlist level, at your design level, if you are able to minimize the logic, then you will be able to you might be able to meet for 1 nanosecond. Okay. Now say per se you are not able to minimize in design. That's the maximum I have done. In design side you have done, that is the maximum that you have done, and that's the minimum logic that whatever you are right now seeing, this is what is minimum. It cannot be reduced further, then it will not be functioning like this. It will be functioning not as a counter, rather something else it will be functioning. So I'll not be able to change the design side. What else we can do?
Modify timing constraints.
Timing constraint, we are only giving the clock time period only. No, what do you want to modify there?
Sir, can we alter Clock
Tell me.
period. Will altering clock period will help.
So we have already modified the clock period. We have already altered the clock period, and that's when we are not able to meet. I wanted my primary question is I wanted to keep my time period as 1 nanosecond only, and I wanted to meet for 1 nanosecond is my requirement. I wanted to meet for 1 nanosecond. Prithvik, you were saying something. Can you unmute and say? I wanted to get more clarity on that.
We need to reduce the propagation delay of CMOS technology.
Propagation delay of CMOS technology. How will I do that? Can I
Like increasing the capacitance, load capacitance, or like decreasing the load capacitance.
Is it in my control?
Like it is in fab control, right? Okay.
Correct. It's in the fab's control, right? What else? I have reduced my logic. Now that's the maximum I can do. What else I can do? There is one more thing that I am expecting an answer.
Library setup
Definitely have.
time, library setup time. Okay, that is fixed, right? Library setup time.
Someone else was coming in between, Satya. Who was it?
Sir Jivan Roy.
Jivan, tell me.
Sir, sir, we are control clock speed using flip-flops.
Come again?
Sir, I can control clock speed using flip-flops.
No, I think you are off the context. I'm asking you. This is the net. This is the path. We have the flop here, the source flop and the destination flop. Between that, these many combinational cells are there. Combinational logic is there. Now I can't change anything in the design. This is what finally. But I have the time. My requirement is 1 nanosecond. But still, I'm getting violation as minus 0.39. I wanted to make the slack as 0. What else I can do? Let's not waste the time. I will give you some 10, 20 more seconds.
Sir, this is very crude, but is it possible to change the constraint to implement a different like FF or different components from the libraries?
Good, Jayavardhan. So what you said is in a way right. Now, if whatever I have ran here for synthesis, I have taken up for this. What is the technology node I have targeted for? For the synthesis, what is the technology node I am running? What is a fab technology node I am running? You are not aware of it?
SCL 180.
Yes, it is SCL 180 nanometer. Okay, this is the technology node. SCL 180 nanometer is a technology node. For SCL 180 nanometer, I am not able to meet for 1 nanosecond. Now, if I change that to say 130 nanometer, to say like 90 nanometer, to say like 60 nanometer, to 45 nanometer, will I be getting the same thing?
It would vary, sir.
It will reduce.
Yeah, it will reduce.
Yeah, and your time period, you'll have a good frequency.
Yeah.
So there is only, so my entire conversation is shrinking to 2 lines only. There is only 2 things that you can do. Either change the logic or change the technological fab that you are targeting.
Yeah, the logic is the combinatorial logic, right? Design.
In design, whatever you want, you can do. I'm not saying logic. If you, for example, one thing is that people they usually do is, so since you see, if you see the levels of logic, we say it as levels of logic. Levels of logic is starting from here, it goes to an AND gate, to an inverter, to an AND or invert, to an XNOR, then it comes to D flip-flop. These are the levels of logic that the data is going. So what they will do usually is they will break these levels of logic by introducing another flip-flop in between somewhere here. Then what will happen? My flop to flop will become, my source flop will become this, and some another X flop will come and sit here. So my entire flop to flop is broken, and this path will go somewhere below, somewhere in the nth place it will go, because it is going to be the shortest path. It is not going to be a critical path anymore.
Yeah.
So that is something it's called as like you pipeline the design with somebody. I think Nandita was saying. Nandita, yeah. Nandita has said like you can pipeline the design, or you can break the design, and if that is something that is not hampering the functionality of your requirement functionality, then you can go ahead. Okay, so clear until now it's clear.
Yes, sir. Yes.
Okay, because these are some aspects that I will be asking in exams. So good that Satya has brought this question. Yeah, thanks to Satya.
Thank you, sir.
Okay. Now, Kuldeep, scaling. Yeah, we'll talk about scaling a little later, because everybody has to understand. Yeah, Satya.
There is one question in the previous video asked by Pratik. You asked us to remind. I don't remember that question. Maybe we can discuss now or later. I mean, just to remind on that.
From who was asking that?
From Pratik, I think, right? Pratik or somebody. That was the end of that session actually.
Yeah, I don't remember.
On the orderliness or something, some processor orderly something.
Yes, sir. I
Pratik
have
can ask.
from last class.
Yeah,
Yeah.
Pradeep, you should have reminded. Satya is reminding. You should have reminded that. Tell me, what was the question?
Okay, sir. I will paste in the chat once.
Okay, you can place in the chat. Meanwhile, we'll start the session. By end of the session. Oh, okay, you have already kept it ready. Okay. Sir, in a processor, we have different hardware blocks, and each of them will get different slacks, either positive or negative. How we manage those things to get correct information at right time at particular block. Okay. Okay, let me share my screen. Okay. Fine. So, see, for a design like processor, okay, say this is your chip. And in processor, you have multiple units. Say you have an FPU, you have some control registers, then you have your bus, AXI bus and all will be there, AXI AHP bus. Then you have peripherals. Then you have core, computing core. So a lot of other components are there like this in your processor. So what during implementation, once it is synthesized and it comes to the implementation stage, how will that be taken as this? Usually if the processor, if the design is very big, if it is not going to be between less than if the design is more than like say 10 lakh cells are there in the design, then what they will do, or they will or if the requirement is also like it has to be performed in different blocks, then what they will do is in synthesis itself they will consider each module as different blocks. say FPU. What they will do only take FPU, synthesize it, and generate a netlist for FPU. And what it will be taken as, like, this is your chip. Inside that, for FPU, FPU will be considered as a block, and there will be inputs pins and output pins for FPU. Other aspects of your design, say this peripherals, AXI bus, core, control registers, will be considered as a separate block. So that will be considered as a, say this is block 1 and rest of the thing is block 2. And then you will have IO pads above this. These are IO pads. I'm saying it is pads, not pins. So this is for a full chip. So if you consider B2 plus B1 is a full chip. But if you consider only B1, that is a block. What you do is you synthesize FPU, you get the netlist, take that netlist and do the entire process of floor planning, partitioning, floor planning, placement, CTS, routing, everything you do for this block alone, and you put it inside this full chip. Okay. And rest of the thing for B2, you also do, for B2, you do floor planning, placement, routing. Then you you instantiate B1 again, and then you complete the implementation. Okay. So this is like divide and conquer. Like you take critical blocks, which is going to be taken, given special care, because like blocks like FPU and all, it is like compute intensive. Okay, that has to be taken care separately. For that, the timing has to be met separately, and then that is brought inside the full chip, and then again it is going through the process of again timing is checked, keeping as it is in full chip. Then if the entire chip is the timing is met or not is checked. So basically what I'm trying to tell you is, like, for every block, for each of them, you will have different slacks. Yes. So for you have to just check. We have to just check whether the slack requirement is met for every block. And your timing report that you are seeing, no, like whatever timing report that says the first path is going to be the critical path, and if that is met, then rest of the paths are obviously met. So these are some aspects that you have to see, and this is how you manage. Is that okay, Prithvi?
Yes, sir, I'm getting.
Okay. Okay, so that's all. This is like whatever I have told to Prithvik now is going to be part of the next advanced module that we are going to cover. In that it will come, but since the doubt has come, I have just tried to clear that. Now let's move on. Certain things that we have to see in static timing analysis that we were that we are going to see now. Okay. So for doing static timing analysis, what is static timing analysis is, see, now you have 4 different paths, 4 different timing constraint paths, and you have to meet the timing in all the 4 different paths. For that, how do you do that timing analysis? How do you check that? How do you, in your design, in your chip, you wanted to check whether this timing is met or not? What is the strategy that we are going to adopt for doing this checking? Okay, there is in timing analysis, that is something called as static, and there is something called as dynamic. Dynamic timing analysis is something, it has a lot of disadvantages in doing that, because you really don't know whether all the functional paths are covered or timed and all, you will not be able to see during dynamic timing analysis, which is not recommended also. And it does not distinguish also between functional and non-functional paths. So something like that. So dynamic timing analysis is not usually encouraged. Usually, no, it is not at all encouraged. Only for that's why we come to static timing analysis, where it is more. You will have the control over the analysis. You will know whether your design will work for a particular time, for a particular time frequency, or it will not work. That conclusion you will be able to arrive at doing static timing analysis. So so basically, what here you will do is you will just fold all possible transitions. All possible transitions means like in the entire circuit, in the entire chip, you will have my inputs coming and it is going to the flip flop, and then it is sent out of the flip flop, and then it is going to another flip flop, then is coming out of the chip. Wherever these all signals are coming in and going out, I'm mentioning that as transitions. Okay, for all possible transitions, it is like consider to be into a, for all possible transitions is into a single cycle. That what does this mean actually is, you for single clock cycle, in the single clock cycle only, you are going to check whether I am able to meet my timing or not. That is the first assumption or first target that we are setting up for doing static timing analysis. So when you are able to meet timing in one particular clock period, timing in single cycle, if you are able to meet the timing, then it is obvious that the next cycle also you'll be able to meet the timing. If suppose if I'm considering not a single cycle, if I'm going to consider 2 cycle, then I really don't know whether I'll be able to meet the timing in first cycle, or whether I'll be able to meet the timing in the third cycle. I don't know. So to tighten it up, I'm considering that if I'm able to meet the timing in one cycle for all possible transitions in the design, then my timing analysis, whatever I'm going to do after that, is meaningful. Getting until now? Any doubts?
So, sir, if we are performing STA, then we won't be needing the report you were showing earlier, right?
No,
Timing
we are considering that report. We are keeping that as the base only. We are not bypassing that. So STA is doing whatever the timing report it is giving, right, is based upon the concept that I'm telling you now.
That the STA shown is for one cycle, right, sir? Till now, what we have seen.
Yes. Okay. Then what you have to say is, like, there is assumption that like your signal becomes stable at latest possible time. Also, your signal becomes unstable at earliest possible time. So these are two assumptions. Okay, I'll explain this when I come to something called as a setup and hold timing analysis. Okay, so maybe I'll try to explain it now. See, your signal as in, it could be a clock signal or it could be a data signal. There are two aspects only that is involved inside the chip, either clock signal or data signal. Other than these two things, is there any other signal that is there? No, right? Is there any other signal you have inside the chip?
No, sir.
Okay, so you have only data and clock. Okay, so these signals become stable at latest possible time. That means as early as possible when the signal is coming inside from the outside the chip. When the signal is coming inside the chip, it becomes stable. Stable as in it has to either go to a 1 state or 0 state and become stable at the latest possible time. That is one assumption. Second second assumption is either the state signal has to is if it is unstable, it has to be unstable as early as possible. It has to be unstable and then it has to become stable at the latest possible time. So that are the two assumptions. That means that has to be taken care after the chip is manufactured. The signal, while you are sending the signal, you have to make the signal stable as latest as possible. And then you have to send the signal inside the chip. So these are the two assumptions for doing static timing analysis. Okay.
So this we are talking about data signal, right? Or clock signal.
Yes, data and clock both has to get
Both.
stabilized.
Okay.
Okay, so basically what we are doing at static timing analysis is, see if my design works at these extreme conditions. Okay, these are some extreme conditions what I have put up, right? If my design is able to work at these extremes, then we can guarantee that it will be able to meet the timing and it will be able to do, I mean, my requirement is met. Okay. So I'll write it down here. So if the design works at these extremes, we can guarantee it always will. Okay. Okay. So
the by extremes you mean like in one cycle, right? In single cycle.
yeah, one is that this is one extreme in one cycle. These are also two extreme conditions only. These are we have considered as an assumption only, right? These are some extreme assumptions that we have made. Can anyone tell what does a propagation delay means? This is something basics from Maurice Mano.
The time difference between input arrival and output arrival.
Yeah, that is one way of telling it. Okay, propagation delay, for example, if you are considering a flop to flop path, so if you see the propagation delay here means my data is sent through this D pin. Okay, there is some time that will require for my D pin data to be latched. I mean to be captured by queue. So there is one amount of delay that is there inside this D flip flop. So this is considered as say T1 delay. Then this data comes out and goes inside this combinational cell, combinational logic. So let me consider this as T2 delay. And then it goes to this D pin and then it goes next. Okay. So my propagation delay is the amount of delay that incurs inside each cell. Okay. Inside each cell, there is an amount of delay where that cell takes for taking the input and passing it to the output. Say, for example, inside this combinational cell, you will have AND gates. And if my data goes inside this AND gate, and then there will be amount of delay, say delta D1. Okay. Similarly, you will have for other gates, all those delays is considered as propagation delay, and that is T2. So my propagation delay for a normal flop to flop will be T1 plus T2. Okay. So what compromises these propagation delays? It is a function of like few factors like one. Yeah, tell me.
So propagation delay is T1 plus T2 till it arrives at the D input of that next flop, right, sir?
Yeah, then
Or
for next flop, next path, I will consider this flop and take this T1 here.
okay. Till up to that point, we will consider T1
Yeah,
plus
yeah.
T2. Okay. And is this same like the setup library time also we are considering the same, right, sir?
Library setup time is different, sir. It is here. This is something that is different. Setup time is
that is the awakening. That is the awakening.
Rise and fall time of gates in the transitioning that is happening from 0 to 1. Okay, it will not be like this straight. Ideally, you are considering it as straight, but usually what will happen is it will take some time to change to from 0 to 1. So this is called as rise time. Similarly, fall time is like coming back to 0. This is fall time. The output of this AND gate is going to get connected to, say,